All right, great to have all of you in the session. And today, today we are going to talk about computer vision. Even if you are very new to the subject, do not worry. I'm going to start from very basics. This session is of 2 hours, and we will take a break of approximately 10 minutes in the midway. Right now it's 8 o'clock in India, and we will take the break after 1 hour around 9 o'clock. So the agenda for today's discussion is, first we will talk briefly about what exactly is CloudX Lab, the company that we are from. And then we'll talk about the speaker. Then we will introduce you to machine learning. And then we will learn something about gradient descent and backpropagation. We will try to keep things very brief and simple so that everybody from all kinds of background would be able to understand it. All right, feel free to introduce yourself using chat. Maybe we are not able to read it now, but after the session, we will go through the chat. Okay. If you have a question, ask the questions using the Q&A window. Please keep your questions brief, but avoid the chat language. I'm not very great with the chat language. So please keep your questions brief, but avoid the chat language. All right. And using the Q&A window, please ask the question. If you want to respond to something or introduce yourself, use the chat window. Okay. There are 2 windows. One is Q&A, other is chat. Use the Q&A window for questions only. Okay, I may not be able to go through the chat, but I'll be able to read the Q&A. All right, so we'll take breaks after every big topic and answer the questions related to the topic. In case the questions are off the topic and we believe that towards the end your questions will be answered, we might skip the questions right away. Right now. We might skip the questions right now, but we'll tackle all the questions towards the end. Okay, feel free to ask questions as much as possible, and because that's the only way to learn. Okay, in general, we do not skip any questions, but we ensure that every question is answered. All right, so this is the flow of the talk. After the gradient descent, we will talk about neural network, and then a special kind of neural network. We will talk about the convolution neural network, and then we'll talk about computer vision, and then generative adversarial network, and then we'll give you a demo of the face embedding. And afterwards, if time permits, those who want to stay back, we would like to give you a demo of the Auto Cameraman, AI-based cameraman. All right, so great to have all of you in this session. These sessions are known to help everyone to get started. Okay, so feel free to ask as many questions as possible, and I will try my best to answer your questions. So what exactly is CloudX Lab? CloudX Lab is a EdTech platform solving the skill gap in emerging technologies. So learning can be hard without the right tools, specifically deep technologies. So, there is a lot of content, but not engaging enough. The content alone is not sufficient. You require practice. And there is no one course that fits all. Every user is different, and everybody's learning curve is different. The instant feedback in none of the existing platform is available. The deeper feedback on your work. And that's where the CloudX Lab comes into picture. So these are the 4 problems that CloudX Lab is solving. How is it solving is by the way of 2 large components or bucket of components. One is gamified learning, and other is the knowledge graph. The gamified learning consists of online lab, the playground on which you can try all kinds of technologies, you can test, you can learn, you can do the hands-on with all kinds of technologies in the machine learning, big data, and deep learning, and related technologies such as NoSQLs. And We have an auto assessment engine which can check almost on all technologies whether you are performing good or bad. This gives you immediate feedback, helping you understand, helping you play around and understand every component. We use behavioral analytics to analyze how good are questions, how good are the questions, is the question too difficult, is the question too easy, is the question, there is a mistake in questions, and so on. So using the user behavior analytics, we improve the question qualities, as well as we try to nudge the users so that they stay on the learning path. Then we have probably the best in-class content in this industry in big data and AI. And we have designed the various kinds of hooks, like, for example, XP points, there's a concept-wise discussion, and there's a forum, and there is a leaderboard. We also have something called BootML. Those who are trying to quickly build the machine learning model, they generally use the BootML tool that we designed. And also, we are working on all kinds of breakthroughs in the education technologies, such as automatically generating quiz. There is a slide finder in the videos, and so on. The online lab, for which with the CloudX Lab was started, it provides you everything on the cloud, and you can access everything from anywhere, and you have large data sets available there, which are shared with all, so that you don't have to rummage around or try to find out what is where. Similarly, in case you get stuck, we can just quickly debug your account and see what's going on and help you out. And it's a real experience, real learning, in the sense that most of these technologies are server-side technologies, and therefore you generally require a cluster of machines to learn, say, Hadoop, big data, machine learning, and so on. And that experience you can't get on your own machine, and hence we have set up a full cluster for you. It's a very easy to integrate with your LMS, so that you don't have to move back and forth between the systems. These are the various tools that are available on CloudX Lab. Now, this is a quick demo, or you can say the screenshot of the demo, whereby the problem statement is asking you to create a directory, and then it's checking whether you have done it or not. On the left-hand side is the problem statement. On the right-hand side is the environment, or you can say playground. Here is the another kind of playground. We call it Jupyter Notebook Assessor. On the right-hand side, you see the Jupyter Notebook. It's a real Jupyter Notebook which we have embedded into the system, and the system checks whether you are doing something correctly or not in the Jupyter Notebook. These are various tutorials available in various technologies like Python, Linux, SQL, Java, and Scala. These are the foundational one. Almost all of these are free along with the lab. And then we have deep learning, machine learning, and AI for managers, along with the big data tools like big data frameworks like Hadoop and Spark. We keep on posting jobs for our learners, and they can quickly check how well they're doing and are they suitable for the job or not, based on their performance on various topics. This is the discussion forum, whereby lots of questions are being posted right now as we speak, and lots of other people are answering. So in order to stay up to date with the various components and technologies, do come over to the discussion forum. This is the glimpse of the BootML. I leave it to you to take a look at BootML. It's essentially a way to create a project on machine learning without having to type all the code. All you have to do is go through this wizard, and it'll generate the code for you. The knowledge graph is something that is unique, and probably we'll be publishing it soon. It's essentially connecting or guiding the user by understanding about the user, like what exactly is the individual's skill gap. So it does the skill gap analysis so that individual knows what are the technologies they have to focus on. We lies in the quadrant. If we draw the quadrant with respect to practical learning versus the engaging or the more gamified learning, if you draw that on a quadrant, this is the area that we are focusing on, meaning that most of our tutorials or the content is around the practical learning and the engagement. Okay, by the way of gamified learning, auto assessment tools, the engagement remains really high. And the content that we are teaching, the topics that we are teaching in CloudX Lab is really practical and very relevant to the industry. All right, so this is where we lie, and you can see, yeah. These are some of the reviews that our users have given on Quora and elsewhere. So take a look at Quora, reviews at Quora and Facebook and so on. A lot of people have really liked our courses in past and our experience of CloudX Lab. The feedback from lab user, even the people like Frank Kane, who is a top Udemy instructor, they find it very useful. And the IBM Bluemix team is another one, and there are quite a few more people who have really liked it. Okay, I hope my voice is audible to all. Yeah, I can see in Zoom that my voice is clear. Okay, great, great. All right, so looks like my voice is clear and there's no distraction. And these are some more feedback on our course. The learners from almost every university across the globe use the CloudX Lab in various forms. All right, so that's about the CloudX Lab. Just give me a moment. I'll add my teammate to the panel. Okay. Now, moving ahead, the various corporates are our users. Now, this is about myself. I would love to know about all of you. Feel free to use the chat window. After the session, we go through all the chats. So please introduce yourself using the chat window. About myself, I graduated from IT Roorkee long back. Then I worked with large-scale computing. I worked with a company called D.E. Shaw. At D.E. Shaw, we were handling the big data even before the term was coined. Those who are not aware of D.E. Shaw, D.E. Shaw is a hedge fund company and has been into the finance sector for quite some time. And even the Amazon's founder, Jeff Bezos, were working at D.E. Shaw in the beginning. So we had a large cluster in 2002. And after D.E. Shaw, I founded a company in India, in Hyderabad. Afterwards, I joined InMobi and Amazon. The Amazon detail page is what I owned for the mobile devices and the image optimization that I did. After that, we founded CloudX Lab because we saw there was a huge gap in the industry, specifically in the learning industry. I love explaining technologies, and at heart, I'm a software engineer. So that's the reason why we started CloudX Lab. All right, so wonderful to have such a great audience. Right now, there are around 200 people in this session. And we're really happy to have audience from across the globe in these sessions. All right, so just a little motivation behind today's discussion. The computer vision is the computer's ability to see and understand. All right, and this computer vision is everywhere, whether you're taking selfie, or you're monitoring an area with a surveillance cameras or a drone, or using the Google glasses or using a video camera. So everywhere is computer vision. Computer vision technologies can make our life better, whether medical field or home appliances or in the gaming or in the robotics, everywhere the computer vision plays a big role. Now, here is a wonderful slide. So computer vision is actually something very fundamental to the human sciences. In physics, optics, image processing, speech, and NLP, this is something amazing. You'll find that the research that happened for computer vision, say, for example, the CNN that we'll talk about, that was done for computer vision, but it's very much applicable in the speech and NLP. On the other hand, robotics, machine learning, information retrieval, system architectures, graphics, algorithms, and so on, along with cognitive sciences and neurosciences. Everywhere there is a impact or there's a use case of computer vision. Personal story, one of the projects that I'm involved with is about identifying the strength of a crystal, identifying the strength of a crystal from a very microscopic photograph. So this was one of the projects that I was doing with one of the well-known institution in India and abroad. What we were trying to do is we were trying to identify the strength of a crystal from the microscopic imagery. And what we were doing is we had the historical data containing the images of various crystals and their strengths. And using the deep neural network technology or computer vision technologies, we were very successful in identifying or predicting the strength of a new crystal that we have not seen before. And the accuracy was mind-blowing. Accuracy was above 92%. The other physics way of calculating their strengths were giving the accuracy of something close to 70%. But the one that we were using, but the technique that we were using was around the deep learning that we will learn as we go ahead. That one was able to give around 92% accuracy in the strength. All right, we will go into more details probably later point of time because that requires a bit of fundamental understanding. All right, so as we understand that computer vision is basically machine learning today. Okay, so we will start with machine learning. Earlier, computer vision or speech synthesis, or let's say converting, recognizing speech, or other branches of computer science were separate branches. Computer vision, voice recognition, speech synthesis, or video analysis. All of these branches of computer science were separate. But today, they are one. Today, everything has become machine learning. All the rule-based approaches are no longer used. Instead, almost every task is machine learning, be it applying filters on your photos or be it let's say video editing. Everything is evolving from rule-based systems to machine learning. We'll learn about machine learning now. So this is something that is breakthrough of this century, whereby the computer learns by itself from the data. Okay, in very simple words, the machine learning is nothing but the field of study that gives computers the ability to learn without being explicitly programmed. All right, so let's go a little bit more detail. Let's take an example of what exactly is machine learning. Machine learning is essentially learning from examples or learning from data and then being able to predict. So let's take this very wonderful example. What we did was we hooked the computer to Mario. How many of you have played Mario? You can respond using the chat. How many of you have played Mario? Wow. And how many of you have actually won the princess? Awesome. Somebody has won thrice. Wow. Now, so few years back, this person named Tom Murphy 7, what he did was he hooked the computer to the Mario game. How he hooked was he basically was running Mario inside the simulator. In case you are still interested to play Mario on your computer, you can install the simulator, and inside that you can load the Mario. And what it did was the program was continuously pressing the keys and observing the impact. And based on that, it was learning what works, what does not. Okay, let's take a look at this video. So this is the beginning, whereby the computer is pressing the keys randomly and crazily and observing what's the impact of pressing the keys. It died of its own death. It was like a toddler, newborn baby. It did not work. After a while, it started performing a little better. When it learned more and more, it kept trying more and more, and it learned. Do you think he'll cross it? So it got stuck, could not cross it. After a few more weeks of learning, now it's able to play better than us. You can see it has built the intuition. By playing over and over again, observing what's going on, you can see, do you think he'll cross it? See that? It crossed it. Now, it is having no problem at all in playing Mario. Few more weeks and it's expert at Mario now. You can see that? You will see some amazing thing now. It's about to exploit the bug in the game. What was that? The Goomba was falling on it, and it figured out that if it starts moving slowly down, it will get the points. So this is the bug that it starts exploiting. You're going to see some more interesting things. It exploiting another bug. What was that? How did it come back? I have no idea. Other games, when it was playing, such as Tetris, when it could not go further, it kept on pausing it. It kept on pausing it because that was the only way to keep the score. That was the only way to keep the score. It is like in the early childhood when when siblings could not win against you, they'll spoil the game and run away, right? In the similar way, when it was not able to succeed, it kept on pausing the game. Okay, so that was an example of machine learning from the experience, learning from the data to predict the next steps. All right, so question to all of you is that if we have to make this program learn to play other games such as Pac-Man, will you have to write the new rules as per the game, or will you just hook it to the new game and let it play for a while? That's right. So you don't need to explicitly program it. Just now what you saw was it kept on pressing the keys, observing the screen, and observing what's going on with the score. The purpose was to maximize the score based on the past experience. So essentially, the option 2 is right, whereby we don't need to write special rules. We did not write special rules like what is gravity and what does it mean by collision. We did not teach it anything. it kept on figuring out everything by itself. What does it mean by jumping, moving forward, moving backward? What is Goomba? We did not teach it anything. We kept on feeding it more and more data. The lucky part was, in this example, we had the data, or it kept on generating data by itself. And that's what made it, made it learn the game so well. All right. Question from Raja is how to hook it up. Good question. So the way it was hooked in this example was that the game was running inside the simulator. You can find out what is SNES simulator. Okay. And SNES simulator, and basically using the controls, you can read using the memory of SNES simulator, you can read the screen, you can send the control by the hardware interrupts, and so on. Okay. All right. So that's right. Option 2 is correct. Now, the next question that lots of people ask is, what exactly is deep learning? Okay. Before moving forward, there are a few questions that I want to answer right now. Okay. There are a lot of questions from Anu. I would answer these questions and as we go ahead. Okay. So, and Auto Week also. And Shilpa also. I think, Shilpa, I would love to answer your question towards the end. It's a very important question. A question from Amritesh is that, is the program generic for all? This program is generic for all the games, and it is able to play almost all the games. Okay. And, but it is not generic for, you know, let's say for real life. Okay. Because in real life, we don't have that much data. And like even, but the strategy, underlying strategy of machine learning is generic enough that it can even be used in robotics. It is being used in robotics. It is being used in self-driving car and so on. The underlying principles of machine learning, underlying algorithms of machine learning that we're going to talk about today, they are applicable across the vertical, across the problem statements. All right, wonderful question. So moving ahead, and those questions that I'm not answering, I'll answer towards the end. You will get the answers towards the end. Okay, so do not panic or worry even if you are new to machine learning. I'm sure that I'm a good teacher. I can help you learn the basics. Okay, basics, and yet not too boring. Okay, I'll try my best to stay not boring. Okay. Wonderful audience. So great. Now, the nature has inspired many inventions, and the inspiration of deep neural network comes from the animal brain. All right. Yes, Noor, I remember you. Okay. And yes, of course, I remember you. All right. Now, so the deep learning is basically a subset of machine learning. Machine learning is a general term whereby machine learns by itself from the data. The way our program learned to play Mario by the data, we did not explicitly code the rules, if else conditions, or anything else. We did not. We kept on feeding it the data. It kept on generating the data by itself and kept on learning from the data. Of course, those of you might be wondering that to hook it to the game, to set the initial configuration, to use the various algorithm underlying, yes, that's still something that you need to code, and that something is still rule-based, okay? And just that playing the game is something we are not teaching. We are just teaching it how to pick the data, how to learn from the data. Okay, and therefore the program is generic enough to play all sorts of games. All right, now the deep learning is a subset of machine learning in which the algorithms are inspired by the animal brain. Lots of research on animal brain has resulted what you see, computer vision, deep learning, or machine learning today. Computer vision is a general, computer vision is a subset of computer science whereby we analyze the video or we do all kinds of image processing. That's a computer vision. And when and computer vision can be achieved, one, by using the explicit coding like rule-based coding in which we used to write algorithms to analyze the various video or images. Or computer vision can also include the machine learning technique. You can achieve computer vision by the way of rule-based programming or by the way of machine learning. Deep learning is a subset of machine learning, okay, which means using deep learning, you can also achieve computer vision. And deep learning is that subset in which the algorithms are inspired by animal brains. Okay, don't worry, even if you have joined just now, it's going to be very useful to you. Okay, I'll try to keep things very simple. All right, now a question that everybody asks me is, it's fine that machine learning is learning from the data and deep learning is about the neural network, which is inspired by animal brain. At the end of it, all of this is a software. At the end of it, all of this is a computer program. Question is, how does this computer program learns from the data? How does instructions learn from the data? All right, the computer algorithms, how do they do it? Let me just take extremely simple example. So I'll just take this, even if you are already aware of machine learning, stay with me, it'll be useful for you, okay? Let's see, how does machine learn? What does it mean by training on existing data? How can it be trained on existing data? What exactly the logic is? I'm going to take extremely simple example so that all of you, no matter what is your background, you will all be able to connect with it. All right, so this is the general philosophy in machine learning, not only deep learning or computer vision. This is the philosophy in machine learning whereby we have data, we have algorithm. These algorithms learn from the data and generate model. Just like our childhood. In the childhood, we learned by surroundings, by generating data, by generating experience data, that when we jump from here, this happens. Or when we pluck this string, this is the kind of sound that comes. So mental model is being prepared in our childhood. Similarly, in the training phase, algorithm generates models. I'll come back to what exactly happens in this phase. Once we have this model, then we can feed it the live data and it can do the prediction. It can do the prediction, which next step to take, which way to jump, where not to jump. That is the prediction, okay? So question that remains is, what is there in the model and what is there in the algorithm? Okay, so let's talk about algorithm first. Let's say we want to learn to predict salary based on the number of years of experience. Yes, thank you, Malini. That's exactly what I'm going to talk about. Predicting the, let's take an example whereby we'll try to predict the salary based on number of years of experience. Imagine your first year's salary was 2,000, then second year's salary was 4,000, third year's was 6,000, and what will be the fourth year's? And everybody? Right. You were able to do it very quickly, right? So that's right, it is 8,000. Now, if we have to make the machine do it, right? Either we could write the rule saying that add 2,000 to the previous term. Either we could write the rule, but where does this 2000 number come from? That came from our experience, our learning. But what we want is, we want the machine to learn such that it can generically predict the next salary, right? So what we want is, we want to prepare the data. We call them instances. We will say that years of experience 1 and outcome is 2000. Years of experience 2, outcome is 4000. Years of experience is 3, salary is 6000, right? This is what we're going to feed to the algorithm, and algorithm is going to spit out or produce the model. And then once we have the model, we will take an unknown data points, such as 4 as years of experience, and it would predict the salary. This is what we want. Remember the diagram, the T diagram, which we discussed earlier? This diagram, this is what is happening. From the data, we got the model, and from the model, we are predicting the salary. Now, how would we make the computer do it? There are many more algorithms that you may not right now need. But let me just take an extremely simple way by plotting the data, right? So if we teach computer to plot the data, it'll be able to predict your salary. And no matter what is the history, whether it's arithmetic or whether it's something else, it would be able to predict to a larger extent. So on x-axis is the number of years of experience. That's your dependent variable. We call it dependent because based on that, we are predicting the salary. And on the y-axis is the salary, right? For first year, it's 2000. Second year, it's 4000. Third year, it's 6000. And fourth year, we don't know, right? So we fed this data and we asked the computer to figure out a line that fits through the data. Once the computer figures out this line, then we can do the prediction. We can ask this line the line that you see. A line in computer or in mathematics has two things. One, where is it cutting one of the lines near the center? And second, the slope of this line. These two numbers, the slope of this line and the intercept, are the two numbers. That is what we call a model. This line is the model because this line can predict the salary for fourth year. This line can predict the salary for fourth year. So when we feed it the year 4 and we do the projection to it, it predicts that your salary is going to be 8,000. So the line, these two numbers right now are your model. Okay? These two numbers are your model. So this is an example of machine learning, whereby we had the data, computer figured out what line to draw, what line to plot, and based on that plot, it's able to predict the future, the things that it has not seen so far. Okay? This is how the machine learning works. Machine learning is essentially figuring out a pattern in the input data so that we can predict the future, or we can predict the outcome based on the unknown inputs, the inputs that we have not seen so far. A question from Silpa is, show the program of the salary graph in Jupyter Notebook. Yes, we can show that, but since the audience is wider, I'll avoid taking all of you to coding. Okay, now coming back to it, the same program that we just trained on a very simplistic data can work on little more complex data sets, such as this one. In first year, our salary was 2010 and so on. The life is not perfect. You never get a straight line. You never get a straight line. And Okay, so you never get a straight line. So basically, you do an approximation. What you do is you want to find out that line that fits through this data perfectly. You want to find out that line which has the minimum error. There can be many lines. There can be many lines that can be drawn, but probably there will be one line that will have the minimum error. And how do you find out the error? By summing up these values. Not summing up like just sum it up, because this negative will cancel this positive, right? Summing up in the sense that you find the mod or the square of each one and then sum it up, right? So that is called the mean square error. So the purpose is come up with that line, that has the minimum error. Come up with the best fitting line. So this is the very simple example. In machine learning, we apply lot more dimensions. Here it's only 2 dimensions, X and Y. In reality, there are thousands of dimensions, okay? In image recognition systems, you will see millions of dimensions sometimes, okay? Every pixel is a dimension. Now, we could draw many lines. You can see line 1, line 2, line 3. Which one is the best fitting line out of line 1, line 2, line 3? Line 1. Why? Because this error, why we call it error? In reality, on 2, it's actually 3980, but our line is saying something else, right? Similarly, in reality, on year equals 3, the salary is 6,020, but line is saying something else, right? So this is the error. This is the error. And the purpose of program is to minimize this error. How can it minimize this error? How can it minimize this error? How can it find out a line that has minimum error? Either it can draw infinitely many lines. It can just keep on drawing all possible lines, or it can go a little greedily. It can go a little greedily in the sense that it'll observe which direction is giving it profit. It'll go in that direction, okay? So we can do brute force algorithm whereby we'll try all possible lines and try to see which one is closest, but that's going to take forever. That's going to take, for even this kind of simple problem, it might take maybe days to come up with that line if you try all possible permutations of slopes and intercept. This is where a greedy algorithm called gradient descent comes into play. And this is a very, very simple algorithm that you will see all the time, okay? So here is an approach. I want all of you to pay attention to it because this is something fundamental to entire machine learning or deep learning. This is fundamental, okay? So whether you talk about deep neural network or you talk about normal linear regression, everywhere we use the gradient descent, okay? So thank you, Nigel. So what we do is, even if you are not from computer science background or mathematics background, I'm sure that you'll make sense out of it, okay? So the purpose is come up with that line that passes through these points closely. Visually, we can draw it, but we have to make the computer do that, right? We have to make the computer do that because computer also need to learn how to find the line or the model that is fitting your data well, right? So what you do is you make the computer draw a random line. This is the initial guess we call. And what we do is we lift the line a little bit. We lift the line a little bit, okay? And we observe whether it's going in the right direction or wrong direction. Did the error increase or did the error decrease? Okay, if the error is decreasing, or you can say cost function, loss function, there are many terms, but I don't want to confuse all of you. Is the error increasing or decreasing? When we lift it up, what do you think? Will the error decrease or increase? Yeah, decreases, right? Because it's going closer to the best fitting line, right? And when it observes that the error is decreasing, it starts moving fast in that direction because it figures out, okay, there's a way to go. So the next line it plots is something like this, a bigger step, right? And it continues the process over and over again. All right. So when it senses that, okay, by lifting it up, we are going in the right direction, it takes a bigger step. And that helps it to take larger steps. And this is what we call that increase in slope. The next step is proportional to the rate of decrease of error when we change the slope. Okay. Or mathematically, this is what it is. So some constant multiplied by this rate. Okay. Whatever is the rate of improvement, it'll multiply some constant and take that step bigger. Bigger is this improvement, bigger will be the next step. Okay. And so on. So new slope is going to be old slope plus some big number. Okay. Now, if let's say this was our initial guess, this was our initial guess, and we lifted the slope a little bit. We increased the slope a little bit. Now, when we increase the slope a little bit, what is happening? Error is increasing. We are going away. Why? Because the error has increased, and therefore it'll come back fast. It'll come back to this side. Okay. So it's a very great strategy because this strategy is generic. It is useful in almost every kind of problem statement. Almost every kind of problem statement, you can use this algorithm and you can reach to a point of the best results in many cases, not all, but in many cases. And that's why the gradient descent, which is a greedy algorithm. Greedy algorithm means it is going greedily. It is going to the direction where it's getting the profits, right? It is going in the direction where it's getting profits. And it basically does that over and over again. So using gradient descent, the greedy algorithm, we can generally find the best fitting model to our data. All right. And so we start with a random line, increase the slope a little bit and calculate the change in error. Did the error decrease? Yes, increase the slope. Otherwise, decrease the slope. And if the error did not change, probably we are at the best place. So there's no need to move. Okay, we keep on doing over and over. Let me just take one more example of tap. Probably this will be more useful. And you all can visualize. Imagine that you went to a new hotel whereby you don't know which side is hot, which side is cold. And these are, let's say it's a winter season. And in the winter season, you need to figure out the best comfortable temperature, right? So what you'll do is you don't know whether turning it left or right will give you the best temperature. So you'll start from say middle or at random position. What you do is you twist it a little bit. You twist it a little bit, wait for the water to come, and then did it improve your experience? Did it give you the comfortable temperature or not? Based on that, you take the new position. If it's going in the right direction, then you will take a bigger step. Otherwise, you will go back. Okay, and you'll keep on doing this until you will find the best comfortable temperature. Okay, so these knobs that you see here is essentially what we do to the neural networks. I'll talk about it soon. So gradient descent is very, very interesting algorithm. It's so simple that everybody can understand. And it's so fundamental that almost every machine learning, whether it's neural network, whether it's deep neural network or normal machine learning, everything uses some form of gradient descent. All right. So the way you are figuring out the hot and cold temperature for yourself blindly, the computer will also do the same thing. Okay, you will tilt it a little bit and touch the water, observe, is it going good or bad, and then you will tweak the knob and continue to tweak the knob until you're most comfortable, right? So theoretically, almost every human, whether educated or not educated, can do gradient descent really well. Whether they know mathematics or do not know mathematics, everybody can do the gradient descent. All right? Okay, gradient descent as in, why we call it a gradient descent? Because we are rolling down towards the smallest error, right? It's like on a mountainous hill, you are blindfolded and all you're doing is slowly touching the feet on the ground and figuring out which side is the slope, and you start walking towards it because you want to go down till the bottom. So you descend from the gradient. Gradient means the slope, the change which is taking to the bottom side. In case you take out your feet and the slope is going upwards, right? You'll turn back and go down to the other side, right? So because you are on a slope, gradient means slope, descent means going down, right? Now, if we have two knobs, and we don't know how to get the best temperature, what you're going to do is you're going to twist both of them. And people figured out if we have more knobs, we can handle more complex scenarios. If we have more knobs, we can handle more complex inputs. Right? For example, if you have two knobs, you can control two things, the good flow and right temperature, as compared to only one knob, whereby we can't really control the flow and the temperature both. So more knobs means the complex model, more knobs mean more intelligence, more knobs means the more learning. If your situation or problem statement is complex such as playing a Mario game, you might need 1,000,000 knobs. If your problem statement is about recognizing people, millions of people, you will require 1,000,000,000 knobs. You'll require 1,000,000,000 knobs. These knobs will learn very complex patterns in the input. Yes, so knobs are essentially the parameters that we are tweaking. These knobs is what we tweak. These knobs is what we tweak in order to get the results. When we say training the model, what is it that we are doing? We are tweaking the knobs. When we say, this is my model, what is that? It's basically the marking of the, like first day you took the bath in your new hotel room, you marked a point on the knob saying that, okay, this is the point where I get the most comfortable water, so that next day when you go there, you don't have to tweak the knobs again, and you can just go to that point and the water is perfect for you, right? That point is called, that marking of the model is persistence of model, or saving the model somewhere so that you can recall it and use it without any further training. You can just take bath without having to tweak the model. That is the prediction phase. Okay, so these knobs are essentially representing the model or the parameters that we tweak. If let's say we have the input like climate, gender, country, cold and hot, the temperature of the cold or the temperature of the hot water, as well as the flow. So if you have so many numbers and you want to figure out the best flow and best temperature for the person based on the gender and the country and the climate, then you will require more such knobs. You'll require more such knobs, okay? And when we call deep learning or artificial neural network, what people figured out is that if you put the layers of the knobs then you will start getting the better results. Okay, you'll get the better results. Now, a little bit of definition. So this is essentially a neural network. A neural network is what? These are the software units. These are called artificial neural network. This is one neuron, this is another neuron, this is another neuron, and so on. This is the input layer, this is the output layer, and this is called the hidden layer. Please note that these are not the knobs. These are not the knobs. The knobs are these. We tweak the connections. These are the connections between the neurons. That's what we tweak. These are the knobs that we pull in. This is not the knob. This is a neuron. The neuron is connected to other neurons. Those are connected to another neurons. And when we say we are training a neural network, what we are doing is we are tweaking these connection weights. How much to flow the signal from here to here? That's what we are tweaking when we are training a neural network. So this is a simple neural network. This is a deep neural network because it has more than one layer. Okay, so essentially these are the knobs, these are the parameters, these are the things that we tweak when we are training a neural network. All right, so when we have the problem, let's say we have got so much of data, like in this climate, this gender, this country, this much input hot temperature and input cold temperature, we need to get good flow and good temperature, right? Good as in good from this person's perspective. So if we are given this kind of data, the problem of the normal, if we take the problem of finding the best temperature for you in your hotel room, if we generalize this problem for humanity or for more people, we might have to collect the data about the climate, gender, country, and the hot and cold flows, and then the good flow and the right temperature. These things are given to us, and then we have to come up with the configuration of these knobs so that we can get the best flow and the right temperature given these input parameters. So for this kind of scenarios, it has been found that if we layer more and more knobs, we will get better results. Okay, we will get better results. All right. So this is a theoretical example whereby we have gathered the data about all kinds of climates, all kinds of genders, and what is the right flow and right temperature for them. And then we are learning from it so that this model can predict, can give out the good flow and right temperature for given the input parameters. All right, I'm just generalizing the case of yours in your new hotel room. Okay. Now, so coming back to it, so here you might see these knobs and you might intend to confuse these knobs with the neurons. No, neurons are not knobs, it's the connection weights. This, how much this one is connected or not, that is the connection weight we tweak. Okay, now what we do is when we talk about neural network, what we do is we create this complex software program whereby this is a neuron and this is another neuron, and the value of this, the output of this is the inputs multiplied by the inputs multiplied by the strength of the connections. Okay, now what we do is, let's say we want to train the machine to predict what is written by hand. Okay, let's say we want to do something called handwriting recognition using the machine learning, or you can say deep learning. Let's say that's what we want to do. Okay, so this problem statement is generally called MNIST. in MNIST, what we do is we have lots of data of handwritten characters. And from those handwritten characters, we learn to predict which character is which one. We have the input data, or you can say the experience or the examples that we have is handwritten character, and along with what actually is written on that character. So we have image and a number associated with it. So what we do is we take this image, feed it to this kind of a configuration or a neural network, we call it. And neural network is basically this kind of a structure whereby what we're doing is we are tweaking these knobs so that the outcome matches the actual label. Okay, so we take this image, feed it to neural network, and tweak these knobs. These are the knobs. Tweak these millions of knobs so that the resultant is something between 0 to 9, which is matching the actual one. Okay, so what we do is, okay, so what we are doing is given an image, we have to predict what's written on it. So we already have lots of example data whereby we have handwritten characters along with labels marked already. And what we do is we take the image and we expect the system to give out that particular label. Here, it's supposed to give us 8. Okay, now it's supposed to give us 8. So what we'll do is we'll tweak these knobs until we get 8. And then we'll take another image and then again tweak the knobs until we get that particular character. Okay, so we will basically try to tweak these knobs such that we get the probability of 8 as the highest. Okay, and that's what we are going to do. What we're going to do is we are going to basically tweak these knobs here. These connections are basically knobs here, such that we get the desired result. Okay, so what we'll do is we take an instance from the training data and freeze this particular all these connections and tweak only these parts. Okay, and then we freeze the second part and tweak these ones. Now what does it mean by that? We'll try to tweak this and see whether the result is going to the right direction or wrong direction. Then we'll tweak the another one and then see whether the result is going to the closest to the desired or not, and so on. We will keep on tweaking each of these connections till we start getting the great results. All right, and that's how we basically train the neural network. So by the way of tweaking the knobs, by the way of, you can say, adjusting the parameters, we try to match the output as per the given label. Okay, and then we basically, as we train it on more and more images, the end result is very close to what we are looking for. Okay, so we basically, once we are done with training it on 8, then we move on to 0, and then we make sure that we tweak these knobs such that the predicted is close to 0. All right. In the similar way, by the way of tweaking these knobs, we can actually predict male or female in the photo. Okay. So in the output layer, there are 2 neurons. One is for male and other is for female, or we can have only 1 neuron saying the probability of male. If it is 0, that means female. 1 means male. Okay. And these are the input pixels. Every pixel of this photo, a photo is nothing but 2-dimensional dots, right? That's what we call pixels. Some are darker, some are lighter, and so on. So each pixel is an input, and the label that we are given already, that this photo is a male or female, is the output. And we tweak the knobs such that the system can predict the gender of a person based on the input photo. All right. So essentially, the idea is this. Essentially, the idea is that tweak the knobs, or you can say train the neural network, or you can say tweak the parameters in order to get the desired output. Okay, so this is called backpropagation, by the way, if you are looking for the word. When you apply gradient descent on one layer of neuron at a time, that is called the backpropagation. Okay, now, so a question is, image recognition is a deep learning. So image recognition has been done using various techniques. So image recognition is an objective. It has been done using rule-based programming. It has been done using the normal machine learning, like by plotting the graphs, right? It has been done using the deep learning. And why we are studying deep learning these days is because out of all the approaches so far, the deep learning's output is the best. Okay, in case of handwriting recognition of the digits, the accuracy of deep neural network is close to 99.8. The classic machine learning, the performance of classic machine learning was close to 83%, and the human way of doing it was close to 75. Okay, human way of doing it is close to 75, and I'm going to talk more about comparison of four things. Comparison of four things. One, how well the human does it. Second, how well the human's programs do it. Third, how well the machine learning, classic machine learning does it, and how well the deep neural network do it. So I'm going to compare the performance as we go ahead, okay, and you will be amazed at the outcome. Okay, so image recognition is a generalized problem, the objective you can say, and deep learning is one of the approaches. Okay, now further improvements to the classic neural network came from something called convolution neural network, and this is an amazing technique that was, applied on the classic neural network. So what we started doing is, instead of taking one pixel at a time, we started taking a group of pixels at a time and start feeding in the neural network. So just like the neuron of the eye sees sees a full area in the world, similarly, we started using the receptive field in the neural network. So you can see it here. Like, for example, here in this image, this is a classic neural network. We call it fully connected or deep neural network. Here, what we have is a simple one-dimensional neural network, or you can say two-dimensional neural network, because this is the input, like pixel 1, pixel 2 is going here, and these are the connection weights that we will be tweaking, and this is some 10 outputs from 0 to 9, and this is a classic one. It was not giving great results. So what we started doing is, we started taking a rectangle in the input, combine it into forming the input to the neural network. Okay, this is called the convolution. So on the input image, we started kind of moving the camera and then combining those values to give the next layer. And then from this layer, we will start tweaking this connections, and then we'll get the desired results. So this is called convolution, and the convolution neural network performs way better on most of the image tasks. Yes, thank you, Ravi. So it's called max pooling. It's not max pooling. It's called max pooling. If you want more details about the machine learning, deep learning, we have an extremely deep dive course of around 150 hours. That covers entire mathematics along with programming required. But my suggestion to all of you is this, that I can assure you, all of you, that whatever we are discussing can be discussed in extremely simple terms, And that's why I'm not going into maths. I'm not going into computing right now. It just, I personally feel that it's actually common sense that, that you all can understand, okay? So even if you are from non-computer science, non-mathematics background, do not panic, all right? So what we are doing here is we're moving a kind of receptive fields over the input image and combining those pixels into a number. And we are doing it over and over the full image. This way, the relationship between nearby, it starts understanding, okay? So this is called input layer, convolution, and receptive field is that moving rectangle on the input data. And filters are something that we are applying in order to combine the values. Like, for example, there could be vertical filter, there could be horizontal filter, and so on, just like you have Instagram filters. Similarly, we are applying some filters here in order to get the next values in the next layer, all right? Like, for example, if you want to shrink an image, we can apply a simple filter and it'll just shrink. You can do so much magic by applying the filters on the image. You can shrink the image, you can zoom out the image, you can zoom in the image, and you can convert a black colored into black and white. You can make it hazy, you can make it more colorful, you can make it less colorful, you can increase its shining, and so on, by moving this receptive field over the input image. So this technique is so powerful that it figures out almost every characteristic of the image, and hence it is used today in all image recognition tasks. Okay, so all right, so basically what happens is we take an input image, apply all kinds of operations on it, and tweak all kinds of knobs in order to learn from the image so that it gives the right output. This is the neural network that contains lots of knobs. Some are convolution, some are normal neural network. So you can think of this as huge machinery having lots of knobs. Some are called filters, some are called the parameters, and essentially, given an input and given the desired output, it will learn from this, okay? Now, here is a realistic thing. This is something very, very real and something I want all of you to pay attention to. This is extremely, extremely important because this is something that has changed the way we look at computers, because the computers that you see have become far more powerful at recognizing things because of this challenge, okay? Because of so many algorithms that were developed to win this challenge. So ImageNet challenge was a classic challenge. It has moved to Kaggle now. The ImageNet challenge was basically this. It has 1.5 million images of around 1,000 object classes such as mite. This is a mite, you can see. This is a mite, it's basically insect. And then the container shape, motor scooter, leopard, and so on. So there are 1,000 such object classes and 500,000 pictures of these objects. So given a photo, we were supposed to predict, given an unknown photo or a new photo, our computer program should predict what is there in the photo. So it has to learn from 1.5 million images to learn to identify these 1,000 objects, okay? And based on this ImageNet, the error rate initially in 2010 were around 28.2% error rate. Then it was 25.8, and now this was the point, 2015, that it crossed the error rate of human. Human on an average commits an error rate of 5.1% in recognizing these objects. And in 2015, the ResNet was one of the machine learning model, the deep learning model, which actually was able to bring down the error rate lesser than human. essentially in 2015, the computer started performing better than us. Okay, so that was ImageNet. Basically, the reason why we are discussing it today, because this error rate has come down drastically in recent times. 2017, the error rate was 2.3. After that, by 2018, though the error rate did not come down, the speed at which the system starts predicting or identifying objects has come down drastically. The speed has become extremely fast. It has become extremely fast at identifying objects. So there are many, many problems related to image classifications. One is object detection, detecting whether there is an object. If there is an object, then what is that object? Action classification, whether the person is running, jumping, sleeping, swimming, and so on. The image captioning, such as whether it's a person on a bike, person running, and so on. You can see in the photo that it has figured out that there is a person and there is a hammer. So the person might be using a hammer. Okay, so these are the various, there are many, many, many more image classification tasks. And image classification is a complex and generalized problem used in many more scenarios, whether it's self-driving cars or it's building a robot. So a typical system looks like this. So we will take a break of 10 minutes and we will be back by 9:30. Okay, so stay with us. We'll have around 40 more minutes of session after 9:30. Please post the time in your time zone. After the break, we are going to talk about, we will show you an example of machine learning, example of face recognition after the break. So do come back. Break for 10 minutes, back by 9:40. 9:30 p.m. IST. Great, great, wonderful, wonderful set of questions and great set of audience. I'm extremely happy to have such an amazing audience, and people from various countries have joined in. It's very rare to have more than 200 people in a session. I have seen many sessions from different presenters, but I'm actually very, very humbled by the audience today. All right, I hope I'll be able to do the justice to your time, and I'll try my best to do so. And okay, so wonderful, wonderful. All right, now this is where we were before the break. So we talked about how the error rate in the image classification is going down year over year. And in 2015, the computers actually started doing far better job than human. And there are many, many use cases of image classification, whether it's detecting what object is it, or identifying what action is the object doing, whether the person is jumping, swimming, running, sleeping, or sitting, or operating on something. So a typical CNN, the convolution neural network, essentially a lot of knobs, some in the rectangular fashion, some in the linear fashion. Those knobs arranged here, that neural network basically cuts it into rectangles and figures out whether this image is having cat, dog, or car. What is the probability of each of these objects? So given this object, we have to figure out the probabilities of these objects. That's what a typical CNN does. All right. So there are many kind of computer vision tasks. One is called semantic segmentation. In this, what we do is we identify the border of the object. So this is cat, this is grass, and there would be trees, and there are mountains, and there's a sky. So here we have to identify pixel by pixel the border of the object. That's called segmentation, or you can say semantic segmentation. Okay, and then the second one is called localization or classification, whereby we are finding which object is it and what is the border, what is the rectangular border that is surrounding the object. Third one is called object detection, whereby we have multiple objects in the frame and we have to identify the rectangles surrounding them, right? And then the third one is multiple segmentation, or you can say instance segmentation, in which there are multiple objects and we have to name them and put the dots around it. So when it comes to multiple objects, these problems become the other problems. Like this one becomes instance segmentation and this one becomes object detection. All right. So there are many kind of computer vision tasks that you can that you need to perform usually. A common question is, how does it actually work? How does it find out a rectangle or a point or a segmentation, or how does it figure out the boundary of the object? So what it does is it cuts the images into smaller rectangle or bigger rectangle or lots of rectangles. Okay, and given this rectangle, the neural network figures out whether it's a cow or a grass. For example, this one is a grass, while this one and this one is cow. Now, based on this, once we have identified all the rectangles in the image, we basically overlap these rectangles, saying that this rectangle and this rectangle combined together is a cow, right? And so on. So this is basically the sliding window. And using these kind of techniques, we identify the segmentation. We do the segmentation or we do the localization, either of them. Either we figure out the exact boundary of the object, or we figure out the rectangle surrounding an object. All right. These are the various algorithms to do the object identification or the computer vision tasks. One is RCNN. Then came fast RCNN, the faster version of it. Then another one called faster RCNN. Then mask RCNN. Then YOLO and YOLO v3. YOLO v3 or SSD, single shot detection. These are the two algorithms that seem to perform really great as of today. You will be generally using either SSD or you will be using the YOLO v3 in order to do the computer vision, in order to detect the objects. All right. These are all done by the algorithms. You just need to understand how to use these algorithms. Okay. All right. So let me take some of the questions and then I'll be back with the remaining part. Now, a question from Sagar is, I understand most of the ML algorithms are through eventual consistency, correct? If so, how can these be tested? Most of these algorithms are approximations. Therefore, the way we test them is by showing them unknown instances and build our confidence on the algorithm by testing them over various kinds of images. Okay, there is a full theory around it, understanding the measures on how you measure them, like should it be precision, recall, and so on. There are many techniques around building the confidence on a model or a machine. Okay. A question is this technique using pre-processed image or raw image? So most of these techniques are on raw images. Pre-processing is part of the neural network. Neural network actually does the pre-processing by itself. A question is what fully connected is differentiable? Yeah, I don't want to get into the mathematics part of it. You can come over to the discussion forum and I would love to answer your question. So come over to the discussion forum and just click on the discuss.cloudxlab.com. Okay. I would love to answer your questions. A question from Sugidvan is that how would we know that the further training is not required? A very good question. Probably this will help others also. I'd love to answer this. So question is how the system will know that the further training is not required. So what happens is if you train an algorithm too much, it starts memorizing. Even though the algorithm might perform great on the instances it has seen, meaning the textbook, but will not perform great on unseen exam, or you can say exam book, right? Therefore, when the moment it starts to perform bad on unseen instances, you should stop or you should regularize it, okay? So the behavior of a model or algorithm is very similar to human in that after a point of time, it starts memorizing. If you force it too much to learn, it will start memorizing instead of building a correct model, okay? A question from Anup is what is content gamification? The gamification is basically gamifying something, giving the reward and punishment so that you play the game, okay? All right. I hope, Auravik, this session has been useful to you because we started with the basics. Otherwise, come over to our discussion forum. I would love to answer your questions. All right. Question from Geetika is, but wouldn't you want to tweak the constant too? Yes, that's right. Thank you, Geetika, for that question. I just wanted to keep the model, my lectures simple. We actually tweaked only the slope in the example, but we would like to tweak the intercept also. Good. Okay, in the same way, exactly in the same way. All right. Now, question from Galaxy S10 is, can you clarify the role of neuron in the neural network? Basically, neuron is just a conceptual algorithmic part whereby it's essentially there are connections coming to it and it's giving out the results. Okay, that's the neuron, and the connections are something we tweak in order to get the results. Okay, the output of a neuron is essentially connection weight multiplied by the input and then transformed by the sigmoid function or any other activation function. You can take a look at the detailed course at CloudXLab. I have covered everything in far more details than this session. The session was more about image processing and the computer vision specifically, and I would like to confine myself there because the machine learning is a huge area. I would like to keep it very simple so that you are not intimidated by the unnecessary complexities, and yet you walk away with something useful from this session. A question is, how do we identify if there are multiple faces inside a single image? And isn't it clear like having different races black? Yeah. So basically, we can train a model on a balanced data set with having different races, and that were different colors of the faces, different people from all across. If we have a balanced data set, our neural network will equally learn all kinds of faces better. Question from Malini is, typically how many images would algorithm like YOLO3 will be trained? Quick answer is millions. Okay, millions. Yes, that's a very good point. Human is far more efficient when it comes to learning, though algorithms are not that efficient when it comes to learning. Question is, it is, it is required continuous watching model results for data accuracy, which would be very difficult for big input data. So that's right, but there are mechanisms in which you can watch the data accuracy by sampling and so on, or by using a big data stack. Okay, thank you, Vidya, for answering that question. Question from Dinesh is, what is one-shot learning? Basically, there's an algorithm called single shot detection. That one basically tries to look at one image at a time and doesn't go back to the same one over and over again during the predicting. So, okay, so now coming back to it, okay. So question is how AI works in it. Now, I was talking about these algorithms. There are so many algorithms, but under the hood, all of them are using convolution neural network in various forms. Yeah, we are going to do the demo just after this. Now, the YOLO V3 is something that I'm going to walk you through very quickly. So it's a fastest object detection algorithm. Given an image, basically there's a deep CNN, and then it basically, whatever rectangles it figures out, it unions those and detects the boundary. So a deep neural network is, have millions and millions of knobs, and these are those knobs, the configuration. You can take a look at YOLO V3 on their website. They'll give you a good example. Here is a video that will give you an overview of how YOLO V3 looks like. Right? So here we go. Will it work? Okay, let it go on. So in a running video, it's able to detect dog, person. You can see it's the video is from India. And this, by the way, this video is from YOLO V3 website. So it's able to detect so many objects in almost real time. This has been done, this prediction has been done in real time on the video. Okay, so it's extremely fast. Now it doesn't know what is an eagle, so sometimes it's detecting the eagle as bird, sometimes detecting as a dog. So you can see this. So it's able to detect objects in the frame. Right? You can see. What I'm going to show you next is that there is a, okay, here, it doesn't have very good training data on the eagle. So sometimes it detected a bird, sometimes it's a dog, and hence it is not really great. It doesn't have data on the camel. So sometimes the camel is detected as a cow, sometimes as a horse. If you train it more on the camel, it will be able to detect the camel better. It doesn't have the object called camel, therefore it is behaving. You can see it doesn't have camel in the learning, therefore it's just recognizing it as a cow. All right. All right, so one of the things that I could give a demo is of the cameraman, but that will require a little bit more setup, but I'd like to just give you a quick glimpse of what we have done. So this is the setup, because when I'm giving a conference inside a conference, what I want is that the camera should be focused on the presenter. So focus should be on the presenter, as in as the presenter moves, the camera should also move. And for that, we basically built a very simple setup. You can also build it if you are a little handy with these tools. So I have made everything open source. You can take a look at the open source version. What it does is, this is your computer, and this is your web camera. From here, it takes the photo of the person, and then it feeds the photo to YOLO and figures out where is the person in the photo. Based on that, based on the frame of a person in the photo, it instructs Arduino to control the motors and rotates the base of the camera. Okay, rotate the base of the camera. Let me just give me a moment. So it's time for all right, so let me start the video so that you can see me. Hi there. I hope you can see me from there. And I'll just show you the setup. It's a bundle of wires. Okay, so essentially this is the camera, and it's connected to two motors here. One is horizontal one, other is in another direction. So when it sees the photo, it takes the photo of a person, and then basically the feed goes to the computer via a USB. Oh man, it will take a bit of time for me to set up, but I'll just give you another demo. So via USB, the feed goes to the computer, and then by the way of Arduino, it will basically control this device. So I have an Arduino here. I have not yet set up, but it'll require a bit of more preparation to give a demo of this whole setup. And it does work. It does work. And recently, while I was visiting visiting Singapore at Google, I gave this tiny demo. Okay. So let me turn off the camera. All right. So essentially, YOLO makes it very much possible. In case you are interested, I'll just walk you through the source code of this one, so that you can, those who are interested, they can build their own setup. Okay. So in this one, I have made this. I have given a demo of this one in a very, very basic set. And here is the GitHub repository of this code. And what it does is it basically, not this one. Okay, so probably, okay. So here, let me go back. So you can take a look at YOLO object detection. Here in the main.py, what it does is, it essentially, here is probably the entry point. This is the main method of this code. So it takes the control of the motors. This is where it gets the control of motors using the serial port. Okay. This is essentially the place how you control your Arduino, which controls the motors. Okay. So take a look at this. I think this will make sense to you. This one here is the logic whereby it captures the image, gets the biggest person from the image, the rectangle of the person. If the rectangle of the person is not in the center, it moves the it moves the motors. It computes the horizontal and vertical angle with which to move the motors, and then it basically tells the Arduino that at the angles at which it should rotate. Okay, so take a look at this. This is going to be quite useful to those who are trying to see if they can utilize deep neural network in real sense. Take a look at this one. I have posted the link on the chat. Okay. All right. So this was a setup. It requires a bit of setup. Probably we can. I'm not able to do it every time. Okay. Now, all right. This is how it works. It's pretty simple. Now, other than recognizing people, detecting people, there's a lot of things that computer vision is applied. Like, for example, something called dense captioning. Here, it is inferring a lot of things from a photo. There's a man sitting on the bench. There is a man wearing black shirt. There's a man sitting on the table, and so on. There's so much of information that the neural network is able to figure out. Now, this is possible by two things. One is image computer vision. Other is natural language synthesis from here. Okay. Now, something that happened recently, which is recently in the sense that it became practical very recently. So we learned about two things so far. One is predicting, other is training, right? So during training phase, we are training the neural network to detect during training phase, we are training the neural network to match our expectation, right? And during prediction phase, it is able to predict the unknown, predict from the unknown data set, right? That it has not seen so far, correct? So those who are wondering what exactly is GAN, GAN is essentially two neural networks competing against each other. All right. So Goodfellow and Yoshua Bengio and others in 2014, what they did was something very interesting. They took two neural networks, one called, thief, or you can say somebody who is faking the system like a pirate. Other is like a police who is detecting whether it has faked or not. So the generator is generating faces, and the detector is marking it as real or fake. Now, this image generator starts to learn how to draw faces because of the detector. Every time the detector says it's a fake face, it improves itself. When it says it's a real face, it improves itself. So generator is generating random images from the random noise and learning how to create faces by the way of detector. This detector is a pre-trained neural network which knows very well what's a face, what is not a face. So the image generator is continuously trying all permutations of, is basically applying the gradient descent to come up with the face which the detector has to mark it as real. So it is trying its best to come up with the real looking faces. And this became something that we had not imagined. This led to neural networks doing magic. The neural networks, specifically we call them generative adversarial neural network. GAN, generative adversarial network, GANs. They basically are capable of creating faces. Let me just show you a wonderful example. So this is a generator. What it does is, from the random noise, it creates a fake image. From the training set, the neural network is trained to predict the real versus fake, and it keeps on trying harder and harder to come up with real faces that discriminator cannot figure out as fake. Okay, So thank you. I actually posted the link to only the panelists. Let me just post it to all. Okay. Now see this video. I want to show you the use case of the GAN. GAN are capable of creating new faces. Okay, they are so good at creating new faces that you yourself cannot differentiate between real person or a new. Okay, so using this technique, a lot of magic has happened in the computer vision that we have never imagined. Like, for example, here all these faces are fake, created by people, created by the computer. So you can see that this face, when combined with this one, generates this one. When this face combined with this one generates this one. This face combined with this one generates this one. And all of these faces are fake. The GAN, the generative adversarial network, are amazing because they can do this kind of magic. Do you see that? It's able to create, synthesize the face as per our wish. It's able to combine the faces. You see that? All right, so I'm going to give you this demo now. This is what we were thinking. So one technique that emerged out of the deep neural network is called face embedding, right? So a trained neural network can give out this list of numbers representing face. Okay, like for example, this one will give out 128 numbers representing this face. These numbers are generated by neural network such that same image, but the image of the same person would give the similar numbers, very close by numbers. The images of different persons will give very different numbers. Okay, so basically these numbers represent the faces very uniquely. And this is something that was a result of the generative GANs. Essentially, the face net and the other algorithms, they can convert a face into a list of numbers. And using this, we can do a lot of magic. I'm going to show you some good magic. So what I did was, here we took the top 1,000 actors and actresses from the IMDb, and this is my photo. We converted all these faces into these numbers by the way of neural network called FaceNet. And I also converted my face into these 128 numbers, right? And using so what we started doing is we took these numbers, compare against each of these numbers, okay? And what I found out that I look like this celebrity. I look like this celebrity called Suraj Sharma. And it is very interesting that he actually, when around 15 years back or 10 years back, I actually look like him out of the entire top 1,000 celebrities of IMDb. So this is a very, very interesting way of doing a lot of magic. So if you want to find out which celebrity looks like you, you can probably use this technique. Let me just share with you the code that I would like to show you. Let me exit from the full screen. Okay, so this is the code that I wrote. It is something that you can also use. So here is my photo. This one, sandeep.jpg. Okay, and will it open? Yeah, this is my photo. And this is don't go with this. This is a download images script which will download the image from IMDb. Here are the images of celebrities. Okay, here are the images of celebrities, and here is the find similar actor code. Okay, so what it does is it calls calculate the phase distance method on the existing folder and my image. Okay, and this piece of code, what it does is, first of all, it converts existing folder into those numbers that I talked about. This part, the first part is figuring out these numbers, and this is where that magic is happening. So using the face recognition API, I was able to load these images, and then the next part we did was loaded my face, this particular image, and generated this. Okay, so let me just show you. Okay, you just have to clone this repository, that's all. You can just clone this repository. Okay, you can say clone like this. Okay, or you can just you know, see what I'm doing. And since I have already cloned it locally, okay, all I'm doing is go to this folder where we have kept it. Okay, this one, and let me just run it. Find similar actor, find Python find similar actor. Okay, let me activate my work environment. Okay, so when I'm running it, it's essentially running this piece of code. What it is doing is it's finding the image similar to sandeep.jpg in the existing known images. Okay, existing known images which are loaded from this folder. Okay, so it's loading the new images, converting the images into those numbers, a list of numbers. We call them face embedding. So using face embedding technique, you can do lots and lots of magic. Find similar images, find the expression of the images, and so on. You can find the genders of the images. You can apply further neural network on these numbers. Okay, it's still loading the images. Around 1,000 images are there. Okay, so it's loading each of the images, converting them into the embeddings, the face embeddings. It says that sandeep.jpg is not there, Sandeep1. Okay, I'll just change, I'm sorry. Okay, I'll just keep one. Okay, I'll just comment out the other experiments that we were running. Okay, so what we are doing is we are essentially first loading all the images of people, of the celebrities, then converting them here. After loading the image, we are converting them into the face embedding. You can see face encoding or face embeddings. And once we are done with that, then we are converting my face into that encoding. And once we are done with this, what we are doing is we are finding the distance between known encoding and the encoding of my face. And from these distances, I'm just picking the smallest one, the closest to my face, and that's where it is giving that result. Okay, that's where it is giving that result. So let's just take a look. A question from Satyajit is, why negative numbers in the list? RGB will only be 0 to 255. Yes, that's right. But see, it's not RGB. It's not the pixel values. These are some numbers that characterize your face. It is not a question. Good question. Thank you, Asutosh. It's not based on cosine similarity. It is based on the Euclidean distance. Thank you, Satyajit. Okay, I tried cosine, but I didn't like the result of cosine. There are many ways to compute distances between two objects. So this is the guy who my photo looks like. My photo is, okay, right? All right. I hope these examples, these piece of code would be useful to you. Okay. And okay. So basically, if you are looking to learn further, know more about it, you can enroll for our courses. These courses are one of the best in industry. All of them are gamified. If you are looking for engineering, because in our typical scenario, you would require to know both parts, the machine learning as well as the engineering. Therefore, my strong suggestion will be that you go for either or both of the courses. And these are one of the best courses in the industry because they are very hands-on. They come with lab whereby you get to do hands-on without installing anything, and you get the experience of real cluster. And those who are looking for a course whereby they can understand the mechanics of machine learning and deep learning and AI, I would strongly recommend you to go for AI for managers. This is a unique course. We have dared to create this course whereby we've tried to explain every hardest concept of machine learning without maths and programming. And we have tried our best to keep this deep. When people hear that AI for managers, people think that it will be a shallow course. This is not a shallow course. It's a deep course whereby we make everyone learn about AI and machine learning. This is a little futuristic. This is little futuristic because if you think about like the way we learn about, say, playing guitar, right? You don't really need to know how to build the guitar. Similarly, if you think about the auto engine, the diesel engine, you really don't need to learn thermodynamics before learning about the diesel engine. You should at least know how exactly the engine functions. There's a piston that moves back and forward. So here we are abstracting out the details which are not required, but we're going deep dive in understanding every part of it. So I would say that if you are not from maths background, go for AI for Managers course. If you are looking for learning maths as well as learning the entire mechanics, I would strongly suggest go for machine learning. If you are looking to handle humongous data and do the data engineering, I would suggest these courses. Okay. All of these are self-paced live courses, self-paced online courses. Live courses are yet to be announced. Rabi, good question. So stay connected. We are about to launch the course with a live course with IIT Roorkee. A question from Abhishek is for computer vision graphics, and I would strongly suggest if you are trying to learn whether computer vision, natural language processing, go for this particular course because this course has 3 parts to it. First part covers the Python, second part covers the classic machine learning, third part covers the deep learning, and it also covers the unsupervised learning. So probably this course is something I strongly recommend everyone. Okay. Whatever is needed for this course, like for example, the coding is required. So we have included the Python course in this one itself. And whatever maths is required, we have taught that maths in this course. You don't really need, differential calculus mastery. No, whatever differential calculus is needed, I have taught in the class. Okay. So in my experience, people without any much maths background, with basic high school maths background, they were able to do it. A question from Takeshwar is, I have experience in database around 9 years. I would strongly suggest that you aim for a career in the data architecture or go for, say, big data engineering with Hadoop and Spark. Okay, do drop me a message at research@cloudxlab. Me and my team would like to help you in your career, as well as suggest you the good courses. We have brought down the prices drastically for extremely expensive courses. We have brought down so that everybody can learn. These courses might sound very less costly, but they are very deep dive. All right. So the overall objective is that with computer vision, you can make your lives better. And feel free to let me know any you know, any question you have. Come over to the discussion forum, come over to our, reach out to us at research@cloudxlab, and feel free to spread the word. Okay, thank you so much. I'm extremely happy that you are able to, you like this course. A question from Arvind is it an IIT course? It's basically with the department, is in conjunction with the department called EICT. It's a project by IIT Roorkee. So we are working with them. We have a MOU at the understanding with IIT Roorkee, whereby we offer the course with IIT Roorkee. So these are hybrid courses from the experts in the industry, as well as from the professors. Some part is theoretical, which is from the professors. Most of it is practical, that is from the industry. Okay. A question from somebody is that I'm working as a quality control engineer in manufacturing industry, wish to switch. Yes, very much. I would suggest that whichever is your branch, whichever is from whatever background you are, my strong suggestion is learning programming is going to help you. Learning programming is going to help you in your area of work. So I would strongly suggest that start with, say, Python or data engineering or machine learning, whichever you feel comfortable with, start there. I would suggest that if you are absolutely new for programming, start with Python. This is a very good course, so it is going to help you because there's a lab and everything available there. A question from Noor is OCR totally different than image recognition? OCR is actually image recognition, just that it recognizes characters and digits. There also is a deep neural network that is applied. It's a combination of what we studied together that is applied in image recognition in OCR. We have used. Okay, so basically the OCR, if you see, it's basically a combination of the things that we learned today. Very good question, amazing questions from. A question from Sunil. I come from IIT Kharagpur, currently working in American Express with 2+ years of experience. I would strongly suggest that you go with machine learning specialization course. This is something that you would appreciate. A question from Anup is, any data science course in future in CloudXLab? Actually, when we say data science, it's actually a combination of this and this. Okay, combination of these two things is something we call data science. Okay, a question from admin is that when we will get the classroom for big data engineering? Good question. So we have not yet planned for the data engineering classroom, but let me just think over, and if we can come up with a live classroom session. So far, we haven't planned it because most of our audience is globally, as well as people who are the instructors or the guide. They're also internationally, connected. So we find delivering online is far better, and delivering self-paced is better because lots of people are prefer to do on self-paced. But in self-paced, there is a huge difference between us and everybody else because ours is more exercise oriented, and exercises are self-evaluated, so you get the feedback immediately and it helps you learn better. Most of our learners are very happy with self-paced course and so on. Okay, so feel free to, don't worry about, don't consider these self-paced course like any other courses. A question from Ajay is any corporate internship? We can plan it out. There are lots of companies who are associated with us. We can definitely help you in the internship. Just reach out to us. Thank you, Noor. I'm happy to get this feedback. Okay. A question from Abhishek is, may I expect a discount if I quick register the course cause data engineering is justifiable for me? But Abhishek, I'll suggest you something, that the course is extremely, subsidized, partly because it's funded, partly because, um, partly because we want to cater to larger user base. So if you think about the prices that we have put in, these are the prices same as the lab. So the content is actually free if you take a look at the lab subscription charges. Okay, so trust me, the prices are actually extremely reasonable. Okay, so I can guarantee that this would be best investment you make in your career. A question from somebody is, it's a very good question. I would love to answer. Currently, many ERP players have come up with their cloud and lots of capability. Good question, good question. So let me answer. So there are so many frameworks you will hear every day, but the truth is, anything that we discuss today or anything that we discuss in machine learning specialization is universal. It is applicable almost in every framework, almost in every technique. The programming language, the framework might change, but the underlying philosophy is same. Underlying philosophy of neural network, computer vision, the natural language processing is universal. And therefore, this course will make a lot of sense, whether you're going with Keras, PyTorch, you're going with TensorFlow, you're going with something else, the philosophy underlying is exactly same. Okay, great. A question from Naresh is that I have 6 years of SQI and BI developer experience. What course? I would strongly suggest that you go for data engineering, and then you will be able to, because your strength is there already. So you'll be able to move swiftly later to the machine learning. So for now, I will suggest that go with data engineering. That's where your strength aligns. If you have already done that, I would suggest that you go for machine learning. Question from Shiva, I've attended big data engineering course. It was very helpful. Thank you, Shiva. I'm extremely happy to get your testimony in public. A question from PKS, how does Swift compare with Python? Okay, I think I can take it on my discussion forum. I would love to answer such questions. Do you guys have a meetup or something going on regular basis? Yes, we do. This is the largest gap we have ever had, but we promise that we'll have more frequent meetups, probably a physical one, probably in Bangalore or probably in Singapore or probably in the US. Either of the places we'll have the meetup soon. Great. I'm very happy to get your testimony, Siva. Thank you so much. Wonderful. A question from Rob is this course different from your previous course? No, it's the same course yet. Rob? A question from Siva is probably the next one we are launching, that will be a little more different. The AI for managers is different. This is something new that we have done. Okay. If you have not visited CloudX Lab for some time. Okay. So that's pretty much. I'd love to, if you stay back and I want to get your question answered, I can answer your questions. Question is, I do believe your word, get enrolled. Okay. Question from Ajay is, I'm CS third year, I'm preparing for Amazon. So AWS can help me. any of your courses, I would suggest that you start with the machine learning course. That's going to help you. Specifically, if you start with the Python course, you will get the very good understanding of Python, and then you can start with the other parts of machine learning. Today, people have started asking the general questions in machine learning, even from the campus. Okay. Can we start lab after going through the classes for a while, or have the lab build on number of days? So actually, the day you sign up, the lab starts. But what you can do is you can just message us so that we can either pause. We can't pause it, but we can extend your number of days. Okay. There is no way to pause. Right? Thank you, Salis. I love the training that you offered to Excel. I'm very happy that to get the public testimony from you, Salis. It really matters to us and me personally. How long the material are accessible in cloud? So materials are accessible are lifelong. The lab subscription is something that expires because that's something that we need to do. Question from Anup is it essential to get certificate by completing projects? Yes. So it's the thing is that in these courses, only if you complete the projects are simple. We guide you, we help you, but you need to complete the projects to get the certificate. Question from Supriya is that not in Mumbai? Yes, probably November. I'm planning to visit Mumbai, IIT Mumbai specifically. Let me see if we can organize meet up that time. We are based out of Bangalore and Singapore, and okay, a question, and we have the main office in the US. How can we get to know about meetups? So come over to the meetup.com. We have a big data and AI group that's very popular. Question from Clement is it possible to get internship in your lab? Yes, definitely. We have a lot of openings. Please send your CV to reach us at CloudX Lab. Okay. A question from Tarkeshwar is, can I stop my lab for weekday? There's no way to pause it, but we can help you extending a couple of days. Okay. A question from Elaki is that I am 10 years experience in IT and have BI background, knows a little bit in data sciences. Which one is best for you? Yes, good question. So I would suggest that this is going to be extremely helpful for you because you are okay with BI. This is going to be helpful. Both of these courses are actually going to be helpful because normal BI has moved to the big data engineering, and the machine learning is the prediction techniques have been absorbed by machine learning. So these both the courses are going to be extremely useful for you. You can decide which one to take first, but I would suggest that you can do that. Okay. A question from Munir is the date for Mumbai. Mumbai will be probably this November, and probably towards the end of October, we'll plan something in Bangalore. Question from Vidya. Demos are interesting. Good. Thank you, Vidya. I'm happy. How can we get a chance to, okay. So you will get updated, just, stay connected with us and just reach out to us. If you have filled in the form on CloudX Lab there, you will get the notifications. Okay. And just check your spam. In case the mail is there, you can mark it unspam so that it doesn't go there. Question from Shiva, would like to tell about CloudX Lab. Reva has MOU with CXA. Yes. So we have understanding with Reva. We help them organize a couple of sessions. Okay. A question from Chandan is, can we get placement assistance after completing the course? Yes, we have some of the recruiters associated with us who keep on posting the jobs, so we can send you. All right. Thank you, Clement. I'm happy that you like the presentation. Okay. Yes, we are a partner. Thank you, Siva, to express it publicly. Yes. I'm working as a project manager. A question from Bhaskar, PHP developer. Which course is suitable for me? Okay, so you are a PHP developer, and I would strongly suggest for you either of these two courses. Okay, and or even this one. Just go through this if it is matching your ambition as well as your skill set, and you can go ahead with that. Since you have a development background, I would suggest that you go for either of these two. Okay, either of these two, because both of these will be needed for you, because when you are, let's say, moving to managing a big data project, this course will be helpful. If you're moving to applying machine learning in your projects, this course might be helpful for you. Now, since you are a developer, it'll be easy for you to go with this one. If you had not been from the development background, I would have suggested you this course. And a question from Paramveer is that your today's session was very informative. Your question is, grow your course will be different from others because I had a bad experience subscribing a course. Okay, thank you, Paramveer. I'm happy that okay. So the way we have designed Udemy is a generalized platform whereby there are courses, small courses. In our case, we have only few courses, but we work hard on improving these courses and providing support for these courses. So we try our best to keep our users happy because we have a very big following. Our user base has a very big trust on us, so we don't want to disappoint them at all. A question from Siva is, can we clone GitHub repository without using shell script? Yes, you can use the desktop tool. GitHub desktop is there, you can use that. A question from Sugidvan is that there are multiple framework tools like Hivepig, why we consider only. So a good question, Sugidvan. Actually, this Hadoop course include everything. It's not, you might don't judge it based on this price or number of hours. This is the most complete course available in the market. It has all the tools starting from the Hadoop introduction, HDFS, Yarn, Zookeeper, and then Hive, then Pig, then MapReduce, then Scoop, Flume, Uzi, and then we learn about Scala, and then we learn about Spark, MLlib, SparkR, and we also learn about GraphX. So this is the largest, biggest course available on the big data on the internet, and everything is practical because that's how we have designed everything. Every topic has exercises which you have to do in the lab, and it evaluates you then and there so that you get a constant encouragement or the correction in your learning. So MapReduce is in both. One is in shell script using MapReduce streaming, other is in Java. So this is probably the most complete course you will ever learn. There is a Java course bundled in it, Scala course bundled in it. Okay. So this is probably the most complete, the biggest course, and yet very affordable with the best certificate in India that is available. A question from Chandan is that, will big data course help me in machine learning career also? Yes. So generally, the path is like this. You got big data. Using the big data techniques, the big data engineering techniques, you clean up the data, then you apply machine learning on it, and then you deploy it. So both the things are complementary to each other, and therefore, learning both is not harmful. It's actually opening you up to a larger career, a bigger career. A question from Sugidvan is that, are you going to use Java to Python? We use Scala and Java in these. MapReduce in Java is almost obsolete. We have provided it as because some of the users want it, but most of the work is happening in Scala, so we have provided the course in Scala. This particular course is in Scala. Spark part is Scala, Hadoop part, MapReduce is in Java, and other parts are available in others. So though MapReduce part is optional because everything is moved to Spark. Now, those who are wondering that why Scala, not Python, because Scala is what we enterprises want. Therefore, we moved to Spark, but we have provided the entire examples here in Python also. So take a look at, say, go to CloudX Lab, go to Big Data, and those who are looking for the Python in Spark, you can take a look at this particular notebook. Okay, so here are the various examples. Those who have completed in Scala, I want to learn about learn Spark in Python. These are the parallel examples to what we have done in Spark in the course. All right, so that's something that okay, so feel free to reach out to us and spread the word around. This is probably the best course available on the internet, the largest course at really, really low prices, specifically because this price, $99, is actually including the lab charges, which are close to $70. Okay. A question from Sugitvan is that what about administration and architecture of Hadoop? For administration, we have provided one of the tutorials on how to install. That's about it. While administration is not in high demand, the architecture of Hadoop is covered in this course. So you will understand everything about Hadoop, and setting up will not be a big trouble because we have shown in a 3 hours video how did we set up CloudX Lab. So you can use that same setup to set up Hadoop and Spark and the entire cluster of your own if you follow that video. It is there in our blog. Okay, a question from Munir is that can you send me the syllabus? I'll just give you a quick glimpse on the course here. You can just take a look at these courses. Everything is public for us. There is nothing which is different in the brochure or the website. Everything is public here. You can just go through it. In case you don't want the CloudX, in case you don't want the EICT certificate, you can go directly for the CloudX Lab only certificate. Okay. You can set it up using on the local machine. It's harder to set it up on local machine because it requires multiple computers. If you're setting up a data engineering environment, it makes sense to set up on multiple machines because you have so many components. Therefore, it doesn't make sense to do it on the local machine. Though you can set up the virtual machine, you can just download the virtual machine and install it, but that would require a really high-end hardware. Okay, if you want to just try out the big data stack, you can sign up for our free lab subscription. That is like it'll deduct $1 and then refund it. So that one you can use. All right. So thank you so much, and these were wonderful questions. So there is one last question. Will you be sharing the presentation with us? Yes, we'll be sharing the presentations. A question from Prasanna: do we need to learn both Java and Python? Don't worry, everything is there in the part of the course. You don't need to worry about the learning path. Okay. A question from Sugitvan is one request: please start the instructor-led training on big data. Okay, I would suggest that we are planning for some of the instructor-led trainings, but in the meantime, try out the self-paced ones. When we are launching the instructor-led training, we will upgrade you into the instructor-led training. All right. We are planning to launch instructor-led training with ML and AI very soon. Question is, what are infrastructure opportunities? There are quite a few infrastructures in the DevOps. There is a lot of opportunities in there. Okay, a question is how the data engineering is different from machine learning. Machine learning is about predicting from the data, while data engineering about cleaning the data and converting the data from one form to another, specifically or managing the data, specifically when the data is really big. Okay, a question is, we'll be sharing, yes, we'll be sharing the presentation with all of you, don't worry. All right. Yes, these are all covered in the course. Perfect. Thank you so much. Feel free to visit the website, Munir. The prices are mentioned on the website. Okay. All right. In rupees is less compared to dollar fees because there is a purchasing power parity and there is a GST applicable on that. Okay. Thank you so much. A question from Sugidman is tentative date for instructor-led training. It will take probably 1.5 months from today to launch the instructor-led trainings. But I would suggest that till then you complete the self-paced course. And if you have questions, just drop us an email. We can have the instructor-led training soon. Thank you so much. And okay, wonderful set of questions. I thoroughly enjoyed your questions. Okay. If you have any questions, please reach out to reach us at CloudX Lab or visit our discussion forum here. This is the discussion forum. Come over to the discussion forum. There's a lot of questions that people ask. I would love to answer your questions. Okay. So thank you so much. It was great. Great set of questions. Wonderful set of questions. Bye-bye. Have a good day. Bye-bye. Have a good day. Thank you for a wonderful set of questions. I enjoyed your questions.